Hello, my name is Jeffrey Beyer, and I'm the co-founder and director of Terra Power. Terra Power turns contaminated sites into renewable energy fields. We aim to clean up contaminated land whilst producing clean power by developing a technology that remediates contaminated sites, which improves health and restores ecosystems, and that produces clean, renewable biogas, which improves energy access, especially for the rural poor, and reduces greenhouse gas emissions. We have completed a successful proof of concept project and are now seeking funding partnerships for R&D, prototyping, and demonstrations. And I'll say up front, success with the ASM Grand Challenge would be hugely transformational for Terra Power. It would allow us to leverage an £800,000 technology innovation grant from the UK government and develop, deploy, and scale our technology in primary markets. So please keep that in mind. The challenge is clear. There's mercury poisoning in over 70 countries around the world, and it's quite severe. Our first target market, Indonesia, suffers from over 1 million hectares of contaminated land, and there are millions more in the countries on this slide. This is how it looks in the field. Deforested landscapes, polluted water and soil, mercury amalgam being heated up and vaporized to extract gold, and that vapor settling on land surrounding these sites, getting into the food chain, and creating neurotoxicity and childhood disability. These sites need to be remediated, and that's why Terra Power is focused on remediation. The standard approach to remediation involves physical soil washing, soil burning, and offsite removal and storage. This process is expensive, it's energy intensive, and it's environmentally disruptive. An alternative approach exists called phytoremediation, which uses plants to decontaminate sites. By comparison, it's much less expensive, it's low energy, and it's environmentally restorative. Indeed, phytoremediation is used to decontaminate sites of lead and cadmium, but it hasn't been used for mercury, and there's a reason for that. The reason is because it produces a lot of contaminated biomass. For lead and cadmium, you can simply burn the biomass in a furnace and the heavy metals remain in the ash. But for mercury, its low boiling point means that burning the plants that are mercury contaminated will re-release the mercury into the atmosphere and surrounding areas. If you bury the plants, the mercury will leak into the ground and water table, and this secondary pollutants challenge has stymied the use of phytoremediation for mercury. Until now, so Terra Power has developed an innovative solution to overcome this secondary pollutants challenge. First, we plant seeds in contaminated land. Those plants absorb pollutants as they grow and clean up land over time. In step 3, we remove the pollutants from harvested plants using a patented process. This involves processing and macerating the plant material in a special solution and exposing the solution to a polymer that was invented in 2016. The polymer absorbs mercury and actually chemically transforms it into cinnabar. Cinnabar is the ore from which mercury is originally derived. Then we're left with a bunch of clean plant matter. We feed that plant matter into an anaerobic digester to create biogas, and the output from the digester is a nutrient-rich digestate sludge. We treat the sludge with the same solution and polymer that we used in step 3 to extract any remaining mercury from it, and that's the process. It's a circular economy approach that's totally innovative and transformative. The saturated polymer, when it's saturated, is disposed of in long-term storage. Even though it's inert, it's a safe way of disposing of it. This is how it looks in the lab. We sow seeds, the plants absorb mercury, we remove mercury from those plants, we make biogas with the feedstocks, and remove mercury from the digestate. In terms of users and customers, we're targeting geographies where mercury contamination and biogas potential overlaps. In Indonesia, one of our primary markets, that includes North Sumatra, West Kalimantan, Southeast Sulawesi, and West Nusa Tenggara. Our other primary market, Myanmar, has identified sites as well circled in red. And our partners in both Indonesia and Myanmar have extensive relationships with communities and governments in these areas. Our impact projections are quite substantial. The annual impact from one medium-sized digester unit can manage the plants grown on 20 hectares under remediation, can produce nearly 2,000 cubic meters of gas, 73 tons of enriched soils, cleaner water from the avoided runoff of mercury into adjacent streams from contaminated sites, and improved health from less exposure to a toxic environment, as well as 2,500 kilograms of fuel wood avoided if you use biogas instead of wood, and the avoidance of 3 tons of CO2 emitted per year. That's all just from one unit. If in Indonesia we achieve a market penetration of just 10%, we can achieve these even bigger results. And remember, Indonesia is just one of 70 countries that suffer from this issue. So we can have really substantial impact from deploying our technology at scale. In terms of the competitive landscape, guys, it's not a full field. And it's not that I haven't done my research here. It's just that phytoremediation for mercury has hitherto been impossible without this polymer and treatment. Flinders University, which invented the polymer, is focusing on industrial processes, like removing mercury from the smokestacks of coal-fired power stations and from oil and gas tailing ponds. Pure Earth, which is a remediation outfit, uses traditional methods, which, as I said, are expensive, energy intensive, and environmentally disruptive. Our approach is genuinely different, and that's why the competition isn't quite up with us yet. Our value proposition and competitive advantage is clear. We're turning a cost into a value stream. Phytoremediation is up to 98% cheaper than standard methods. We're producing clean, low-cost gas, and critically, we're producing that gas near the location where it's actually going to be used. Transport of gas to rural places is very expensive and often prohibitively so. We're supporting the achievement of the UN Minamata Convention on Mercury and the Paris Climate Change Accord. We're improving human health, energy access, in particular for the most disadvantaged in rural places, and contributing to 8 UN Sustainable Development Goals. The business model is quite straightforward. We'll encourage farmers to plant phytoremediation crops on contaminated land, and we'll buy those crops from farmers. We'll also give them the clean digestate to improve the soil health and fertility of their fields. We'll sell biogas to local energy users. We'll sell carbon offsets to international companies that have committed to achieving net zero. Indeed, many mining companies have committed to net zero and are keen to buy offsets that are produced in an industry related to their own mining industry, as our offsets will be. We'll also sell our remediation services to governments and donors. This is how the business model looks over time. There's an initial upfront capital investment in year 1. We're having a build, own, operate model to begin with, and operations and maintenance costs, as well as plant purchase costs over time. And there's also revenue streams from biogas, carbon offsets, and Minamata payments. The global markets for these are very large. Biogas sales are growing at 25% per year annually since 2010 in Indonesia. So there's a really strong market here. Depending on our business model, we may actually buy the poison land at the beginning of the process, and when it's clean, sell it at the end for a big uplift. And I want to reiterate here that this is a really different approach to remediation than normal. Typically, this red cash line just goes down. There's no revenue stream associated with it. We're actually transforming a high-cost activity into a revenue-generating opportunity. It's a real paradigm shift that's going to really capitalize on a commercial driver to push forward remediation and scale up this approach. Our go-to-market plan includes integrating with existing livelihood activities and energy demands in local areas. We're going to engage communities, local and national governments, in particular leveraging the expertise of our partners and their relationships. We're going to model our deployment after the biogas program initiated by HIVOS, the Dutch Development Agency, which has deployed over 20,000 AD units in Indonesia since 2012. It's very impressive. We're going to really leverage the agricultural heritage of farmers who are otherwise dispossessed by mining and supply biogas for productive use, such as mini-grid stability for light industrial or commercial processes as well. We take risk very seriously and have developed a comprehensive risk register on the right. The main technical, environmental, commercial, legal, and regulatory risks are listed to the left. For each risk, we have a likelihood, severity, and impact score, as well as mitigating measures to make sure that we manage risk very, very seriously. In terms of accomplishments, we've succeeded in our proof of concept project with funding from Innovate UK and GCRF, strong partnerships with Loughborough University, which have led to a publication of our results in the International Journal of Phytoremediation in June 2020. In terms of accomplishments for our technology, it's very exciting. You know, plants do absorb mercury. Mercury can be removed from plants. Plants can be made into biogas, and the gestate can be further purified with our technology. So we have a soup to nuts successful proof of concept that we now need to optimize. That's what this future technology pathway is all about process optimization. So we're going to sow test plants, harvest those plants, analyze them for molecular analysis, and then optimize the mercury removal process from both the plant biomass and the digestate, combine that optimization strategy in a technology commercialization pathway in preparation for seed investment. In the longer term, we have planned to achieve technology readiness level 7 or a minimum viable product by 2023, with a better product in 2024, major scale up in 2025, and big commercial impacts thereafter. Our team is very strong. Myself, an expert in renewable energy, climate policy, and entrepreneurship business acceleration for clean tech. Yuyun has 25 years of experience in toxic pollutants and is supporting the Indonesia government, both locally and nationally, and its national remediation plan for mercury. Our partner in Loughborough University, lead partner is Tanya Radu, an expert in water engineering and anaerobic digestion. She was also our proof of concept partner. And David Allen, CEO of Spectrum Sustainable Development Knowledge Network for 15 years, with a background in mining and metallurgy, also supporting Myanmar to develop the National Action Plan on Mercury with support from UNEP. Taken together, it's a very, very exciting opportunity for us. I hope I've explained well the really transformational impact this could have on the health and environment of people in affected communities. So thank you very much for your attention.